Hi, my name's Hazem, and today we're going to learn about the Lockheed Martin F-35 Lightning II and whether it can be hacked or whether there's a backdoor or whether Lockheed, the US government, can shut it off after you buy it. And I made a long video, it was like half an hour, but I'm going to make a much shorter one because people aren't going to listen for half an hour. So the Lockheed Martin F-35 is being used by a whole bunch of countries, and a whole bunch more are buying it, and it has a lot of different weapons. But what it also has is this radar array, which is a software-defined array, and this thing is extremely resistant to radar jamming because it can communicate with other planes and with the ground, and it can laser point its signal in any direction without moving a single part. It can do that all with the software, which is extremely cool, and it can talk to many different planes. But the system's made by Harris, which is another defense contractor that's working on the plane, and it can let multiple planes talk to each other on the Maddle link. And then they also have the older system, which allows planes to talk to each other from point to point with a line of sight if they can see each other. But technically can also talk over the internet, and they can talk to planes even operated by other countries at NATO, any allied states, and even ships. But the crazy thing is we got components from so many different companies: Collins, BAE, Viavi, Harris, General Electric, Pratt & Whitney, who makes the engines, and all this stuff has to talk to each other over what we call a fiber channel switch. So this is the fiber channel, and we've got the radar and the radar and the phased array and the satellite and weapon systems and the helmet. And the problem is a lot of the stuff, every component's made by a different manufacturer, and then every component has subcomponents like computer circuitry, which turn out they're made in China. And then on top of that, you can add aftermarket parts, like you can add like running boards to your car, so customers can add aftermarket devices on top of that. And then if you look, every circuit board kind of looks like this, and so every circuit board has these chips that make really fast decisions about really small amounts of data, like radar sensors and that kind of thing. And you can see just on one chip we got three different, or one board we've got three different chips, 4 to 5 different, whole bunch of chips made by 3 different manufacturers. And so each of these chips has software, and there's no way to read the software on it. And if you're building a plane, and your plane probably has 10,000 little chips on it and all the different components, and there's no way to actually try and read the software on this chip and on every chip that comes to your door and make sure that there's no backdoor in it from China or Russia or some other country. And so now, when you think about it, if you think about a phone like an Apple phone, the Apple phone has a whole bunch of specialized chips for Wi-Fi, cellular network, vibration, the camera, but Apple has a quality control process, so they have a digital signature that's burned into the phone. We call that the hardware root of trust. And what that does is when you try to load the iOS operating system onto the phone, or upgrade your phone, or reset your phone, the phone checks the signature on the file, and it verifies that the signature matches what's burned into the phone. And that means the phone knows that legitimately the software that you're getting was signed by Apple, and so it trusts it. If you try to load software onto your phone that's not digitally signed with the correct signature, phone will automatically reject it, and there's nothing you can do about it. So, but that's great, but remember we had SolarWinds. So SolarWinds made software that many people in the government used, like 20,000 computers ran it, and some hackers got into the SolarWinds system, and they put backdoors into the SolarWinds software, and then SolarWinds signed their software, and then people downloaded the software with the signature saying, oh, this is legitimate SolarWinds software. which it was, and then the backdoors ended up on all their computers because the backdoor was digitally signed. So now you got this plane has what we call a real-time operating system, which is made by a company called Green Hill Software. And so you can think of a plane like a computer, but instead of having like a microphone, a webcam, a printer plugged in, it's got a radar, it's got a missile, it's got a helmet, it's got a cockpit plugged in, and they all got to talk to each other. Now, if your computer is a bit slow and your document takes like 3 extra seconds to print off, that's no big deal. But on an airplane, 3 seconds could mean life or death. So you can't let the software crash under any circumstances, or even slow down even slightly. It's gotta work all the time instantly, and the way they do that is with a special type of operating system called a real-time operating system. And this one is designed to keep each application in a separate virtual space, so that the applications can't actually talk to each other directly. They can only talk to each other through the operating system, and that prevents malicious software from getting in or destroying anything. But they're only as secure as the software that's running on the system, because the software can be bad, and there's a lot of software because there's a lot of different manufacturers, and there's also been a whole bunch of changes. So on top of the operating system, we have the actual software that runs the plane. And it actually took code from the F-22 from the 1980s. That's how they started. And then they added iterations until they got, now we're at our 4th version, which is technically like our 9th version of the software. And every version of software gives the plane more features and lets you add more components to it. But the problem is that the software keeps changing, and it's already been using code that's now 45 years old, some of it, and some of it's new and some of it's old. But if we look at it, the software is like 16 million lines of code. And because we have all these different pieces from all these different companies, everybody has to have access to the code so they can make their own piece work with all the other pieces. So that means we have like 150 companies that had access to the code that runs on the plane. And then remember, each of those pieces has sub pieces which have little chips, and so every chip has its own software. And a whole bunch of those chips were made in China, and there's like, now you can think there's like 30 million lines of code on across the whole plane, and there's no way to check what the code says on all these little pieces. It's impossible. Especially imagine you have 1,000 planes and you have 10,000 chips, so that means you have 10 million chips to check. That's even if you could check, and likely you can't. And so over the decades you've had like 20,000 people with access to the code. And on top of that, every time a manufacturer of a subcomponent has an idea and says, hey, I can make this code a little bit better, they change the code a little bit. So what you end up with is like different combinations of code across all the pieces in the plane, because every manufacturer is doing an update at some random time. So the chips made in 2020 have different code than 2021, 2022, and so every plane literally probably could have almost a different set of code, especially with all the different software versions. So there's like infinite number of combinations, and none of this code is digitally signed like we did with Apple. And so on top of that, you think, hey, I got the plane at least and it can fly, but the plane can't do anything unless you have 3 racks full of servers. So these are full height racks the size of refrigerators, and they weigh like 980 pounds. And every plane needs 3, and these are supposed to talk back and forth with the plane and gather all kinds of data about the engine and the parts and the maintenance. And they let people on the ground plan missions, and that goes into the software, and then the software tells the plane, and the plane says, hey, let's say I need a new air filter and I'm in the Netherlands, and So then the system should say, okay, well, we found an air filter in Toronto. Let's send it to the Netherlands so that when the plane lands, there's somebody there who can change the air filter or create a work order for maintenance. And this was supposed to work completely autonomically, and it never worked properly, and staff had to enter all kinds of stuff manually, and it was supposed to keep classified and unclassified data separately, which it couldn't do. And so now it's in the process of being replaced. But before they replaced it, remember, every single system, doesn't matter which country bought it, this stuff sends all of its maintenance data back to Lockheed Martin. So it's a totally closed system that whatever you're doing, it's sending it back. And so now there's a new system which is only like 4 rack units, so like 2 giant briefcases, and it's basically a server and a UPS, and they've rolled it out only to 4 locations so far. But this system is supposed to work like your iPhone, and it's cloud based, and so it talks to the plane, but it also talks to the internet, which means that anybody at like a call center or the logistics or the warehouse could talk to it. And it's also got classified and unclassified material on the same system. But this thing is open to the internet. So remember, we've got this plane with all this code from all these different manufacturers, including Chinese manufacturers. There's almost certainly backdoors and all of this stuff. And then on top of that, it's exposed to the internet, so everybody can get in. And given the track record of the previous version of the system, it didn't even work properly. Now we got this new system that doesn't even work properly, that they're still rolling out. It's almost definitely gonna have a back door from somewhere. So to say you buy the plane, will the government turn it off? Well, probably not. They're probably not smart enough to put their own kill switch in it, or nefarious enough. But what could happen is a foreign government might have a backdoor, and they might be able to remotely deactivate something. So it's almost impossible to tell. But if we go back, somebody could write some code for one of the little tiny chips in here that could do something really wild in response to a very specific radio signal or photo signal, or certain combinations, or at a certain date and time that we don't know about, and then that could render the plane inoperable, or could render the plane inoperable if it was, let's say, flying in Chinese airspace and the GPS chip detected where the plane was, for example. So you don't know. Nobody really knows what's on here, even the people that are selling it. And then on top of that, there's no way that this is gonna be secure, because it's a massive system, and it's just a mess right now. The old system was a mess, and the new system is rolling out, but we'll see. So if you have any questions, please post a comment. Thank you.